the most important topic, developing container images. Okay, so how do you develop a container image? That's an important question. So every company, that is what their intention is. Whatever application the company have, they should develop a container image and they want to store them inside a registry. That is their, that is their day-to-day job of you, right? Keep on developing the container images and then the code will change. You create a new container image. Then code will change again, create another container image. So every container image will have various version, CoIT front end today, CoIT front end tomorrow, CoIT front end day after tomorrow, right? Every day, every hour, every few minutes, the code will change. So you have to create a new version of your container image. And then whatever container image that you are creating, you want them to be stored inside a registry for distribution, right? Distributing to the other people, other systems, right? Many people or system in your company want to use that image that you stored in the registry. So it's a day-to-day job that you do, or not you manually. Generally, it is done in an automated way, but we will get there. For now, just developing container images is very, very important for any company who decided to run their application in containers. If you are using containers, first step would be make sure that all your application, quite front end, quite back end, shopping cart, train customer, whatever application that you currently have, develop Docker images and store them inside a registry and distribute them to the various people. Make it downloadable by other people, other systems who needs to use that image, right? So that's very important. So we'll talk about how you can develop a container image. How does a company develop a container image? So technically, how to create a container image? You create a container image from a container. You will run a container and you will do stuff inside the container. And from the container, you will commit a final image. Generally, images are created by committing a running container. So maybe you will create a container. Inside the container, you will install Apache. Then you will start Apache, or maybe you will set up the startup program of Apache, because you cannot start Apache inside an image. You just can simply set up the startup program. And then, basically, whatever you want the container to have, you can manually work on the container, copy stuff in here. You can copy the build folder into this container. Then you can make sure that it's located in the www.html, right? All these things you can manually do inside a container. You can work on a container. Actually, technically, you can work on a container. There's a command called docker exec, using which you can log into a container and can work on a container. And after you work on a container, you install Apache, you do all the stuff, and do everything what your CoIT front-end application need, and then take an image. So this would be your final image. Anyone in the world create a container from that image, no, it would run the CoIT front-end application. So that is the way how you develop a container image. You make changes to a running container and commit it, and that would result in creation of a image. And from that image, you can probably store that image inside a registry. Then other people in your company can download that image and then create a container, and then that container will be running the CoIT front-end application, and nobody need to take any extra effort. Take this image and run it, execute the Docker run command. The container should start. That's easy. It should be. It should be that much easy for other people. So when you develop a container, you make sure that Apache is there inside. You'll make sure that the build folder is there in the www.html, and also the startup program is also set so that every time somebody create a container, automatically this command will run, right? Apache CTL -d foreground. This command will run automatically. Anyone create a image, container from this image. So you will make all this adjustment in a temporary container that you created, commit an image and store that image in a registry. Now anyone in your team, any systems in your company can download this image and they can create a container. And now this image has a settings which says every time a container gets created, execute this command automatically, startup program. This is the startup program which would technically start Apache. So this is the way how you would develop a container image for your application, right? And that's the point. So So, right. So, so you should first create a container, right? Maybe in order to create a container, we can use a base image. So there are many images available, free images available in hub.docker.com. There is a Ubuntu image available in hub.docker.com, or there is a Alpine image available in hub.docker.com. And from that image, you would create a container. So there are a lot of official images and non-official images, community images. There are 9 million, over 9 million images already available in hub.docker.com. You can download them. Most of them are public. They are free to download, right? And you can download them and you can, use them. If you go to hub.docker.com, there are many images. If I log out, I'm going to log out in hub.docker.com and I go to the main page. And I click on this explore button. There are over 9 million images, and some of them are official images, Docker official image. What that means is these images are directly managed by the Docker company. And then there are some verified images. So as for some provider, Docker don't manage the container image. The provider themselves will manage it. For example, I am a company. I have a software. I want people to install the software by downloading it from hub.docker.com. So what I will do is, as a company, I would create a container image and I would store that container image in hub.docker.com and I will make it public. And anyone in the world can download that image and use it. So these are images which are free, downloadable. There is an Ubuntu image. So I already told you, right? Container does not contain an operating system. So when I say Ubuntu Docker image, I did not mean a container which consists of the complete Linux and Ubuntu operating system. No, there is no Linux inside the container. Linux kernel is in the host, right? So what is meant by Ubuntu container? Ubuntu container consists of those binaries and libraries that Ubuntu need. Ubuntu is a Linux flavor. So on top of Linux, Ubuntu has different libraries and binaries of its own. So those would be there inside the container, not the entire Linux. Make a note, right? Don't get confused that when I say Ubuntu image in hub.docker.com, that image does not consist of a complete Linux operating system. No, it consists of Linux operating system is already there on the host wherever you are running the container. Then apart from that, Ubuntu has some special binaries, libraries that it developed. Those will be there inside the container, right? Make a note. Make a note. So don't get confused. Alpine is another operating system, but does not mean, right? It's the complete operating system. It's whatever Alpine related stuff. So yeah, just to make sure that you're clear. Otherwise, when you see the operating system's name, you would think that it includes Linux also. No, Linux kernel is not there inside the container. That would be in the host. Okay, right. So yeah, the point is you can download this image. You can use the command docker pull, right, on your Docker host. You may execute this command docker pull Ubuntu. So you don't need to specify any. If it is an official image, you don't have to specify any name here. Docker ID, you don't have to specify. You can simply specify the name of the image. In this particular case, it's Ubuntu. So Docker pull Ubuntu colon latest. If you want to put, you can do, or you can check if there are any other tags that are downloadable. If you click on Ubuntu, then technically, inside this Ubuntu image, you can click on the tag. You can see all the available tags. Latest is there, rolling is there, kinetic is there, various jammy, devil, 22.10, 22.4, Ubuntu 22.4. So various tags are available. So you can choose which one you want. So today I'm going to go with the latest one. So I'm going to download Ubuntu latest. If it is latest, it's not mandatory that you know how to put this. You can simply run the command git pull. Then what happens is an image get downloaded. To your local. It's an Ubuntu image, right? And you can run the command docker images to confirm the image is created. Image is here. I'm going to create a container by running the command docker run followed by the name of the image. So then what happens is a container get created. Okay, sorry. Let me also specify -ti followed by bash. So technically, what I can do is when I create a container, I told you every container are started with a program startup command, right? Yes, Ubuntu container also start with a startup command. And if you want to override that, you can do it yourself. With a -ti option, you can, if you put a command, so bash is technically a command. So I can type the ls command. Let me show you the ls command. So if I pass any command, then that command become the startup program. So whatever the default command that were configured, I am assuming there is some default command, right? I don't know. I'm not the one who created this image, but whoever created this image, there is a default program. Every time a container get created from this image, the default program will run. I don't know what program it is, but I don't want whatever that program is. I don't want to run that program. I want to run the program ls. I want to run the command ls. This I want the startup program to be. So let me try that, from this. So what I'm doing using docker run command, I'm creating a container from this image, and I want this to be the command running in that container, whichever I am creating. So let's see what happens, right? Let's see what happens. Looks like something happened. Looks like container got created using the docker run command. And inside the container, ls command got executed. As you can see, the ls command is printing something, right? It's printing me the output of a folder, whatever the default folder is. Great, so it's working. Now, ls command, you already know it is a short-lived command, right? It is a short-lived command. ls command run and complete within less than 1 second. Within 1 second, ls command finishes and its job is done. What will happen to the container? Did we talk about this? What will happen to the container if the startup program finishes? Container gets stopped. I run the command docker ps now. You can see the container is gone. I mean, this is the alt container created from the alt image. The container which got created from the Ubuntu image, it's gone. It got stopped because the startup program is ls. It's a short-lived command, right? And that's why. So you run the command docker ps -a. You can see a image got created, a container got created. This is the container ID from the Ubuntu image. It was created, and bash ls was the command that I executed on it, and then it got exited after ls command got finished. Make sense? So this is the way how it works, right? And now let me, instead of ls, let me use a bash command. What is bash? Bash will give you a Linux command line. That's what bash is, right? Bash provides you a Linux command line. Now let me run this command. Now actually it provided me a Linux command line, but remember, this bash command I am executing inside the container. So it gave me the container command line. Now I am inside the container. Technically, now I am inside the container, right? You can see the name has changed. This is my AWS machine. In the AWS machine, I have just created a container with a bash command. Bash command with -ti option would technically create a container, execute the bash command in it, and bash command in Linux, it says provide a command line. So it started a command line. I can see the container. Now I am inside the container. I can work on the container just like I work on a normal machine. I want to install Apache. I want to copy the build folder to it. I want to set up some startup program, Apache CTL -t foreground. Anything that I normally do on Linux, I can work on a container. Currently, I am working on a container. I am installing Apache inside the container. Whatever settings that I create, it get created inside the container. So what I just did is, I just created a container from Ubuntu image. I'm just working on the container. I'm running the apt-get update, apt-get install. Then I can, later copy the build folder to this. I can do anything that I want in the container. And the image is not affected, only container get affected by this. And after making all the modification I need, I created the folder www.html, copy the build folder in it. Then I also set up this command to be the startup program. It's not very difficult, You can set up the startup program in Linux very easily. There are some init script that you can modify on Linux to set up the startup program. Startup program means next time when you create a container, what program will run by default. That's what I mean by startup program. So I can do a lot of settings inside the container myself manually. Then I will commit a final image. And this final image is ready to run my CoIT frontend application. I would store this image in a registry. I would I would allow the people to download that image as they want, create a container, and now everyone in my team, every systems in my company can run the CoIT frontend application just by downloading this image and creating a container. Everyone in my team now can simply execute the Docker run command, and a CoIT frontend container will start on their laptop or anywhere I want to start. So this way, this is my responsibility. I want to develop a container image, and this could be the final container image that I develop. Then I want to also push it to the registry. Now it's downloadable by everyone, and everyone in my team, they can create containers as they wish, right? As they want. So, and automatically, since this program is already set as the default program, anyone in the world who create a container from that image, it would start running Apache. So it would start serving CoIT frontend application to people. So this is how you develop an image. You create a container from a base image, maybe Ubuntu, maybe Alpine, maybe some base image. You create a container, make modification to the container, and then you commit that container to a final image. And that final image is what everyone in your team would use whenever they want to create a container. That is the process of developing a container. This is how you develop a container. And it's a one-time action, right? I mean, it's a one-time action, not one time. Every time the code change, you have to do it again. But yeah, the point is, once the image is created, everyone can use it. Great. So actually, when you're developing a container image, it's not as straightforward as that, right? So yes, I mean, it is possible. Whatever I just said is possible. You can take a base image, create a container, install everything inside the container, and commit a final image. That is perfect. That is perfect. That is how container images are developed. But that is not how people does it, because the container image creation is a continuous process. Container development is a continuous process. You cannot, every time the developer make the code change, you cannot, do this whole process all by yourself manually. It's a bad idea, right? You don't want to do that because it's a continuous process, right? Your developer keep on modifying the code, the code front end application, the code get modified, the source code get modified by your developer. And after the source code get modified, you want to create a new build folder. I mean, right? You got the point. You want to create a new build folder. Then after creating the new build folder, you want to create a new Docker image of the CoIT frontend application consisting of the latest build folder. And so if you want to, every time the developer make the code change, then I as a DevOps engineer, I have to take a base Ubuntu image, and then on top of that base Ubuntu image, I would create a container, and then inside the container I would do all the modification like installing Apache, then copying the latest build folder, whatever the latest build folder that has come from developer, and then setting up the startup command. I have to do this process again and again, and I have to create the final image, and I don't like that. I mean, you should not do that. That won't give you any advantage of using containers. So what you should do is you should do this process as layers, and you should use some effective caching, and you should automate this process. So these are the things what you should do. First of all, you should make sure that this process is automated with a single command. We can do this. We can take a base image, Ubuntu, create a container, and inside the container, all the commands get executed, and a final image get committed, and this process should be automated. That is most important thing. And second important thing is that you want to efficiently use some caching. So when I install Apache once, I don't want to install Apache again and again and again every day, every hour, every time the code changes, right? Apache installation has not changed. Maybe the build folder content will change when developer make the code change. So Apache installation, there is no change. Startup program, there is no change. Build folder, there's a change. So only that step I want to enable. So I should use the caching efficiently. So these are the two things I want to do. So every time the code get modified, I don't want to reinstall Apache. I don't want to change the startup program again and again because that is a one-time action and that don't change very frequently. Maybe if it changes, then I want to change it. Otherwise, I don't want to touch them. I just want to copy the latest build folder. So if you want to do that, you should not do everything in one container. You should be creating multiple containers. In the first container, you install Apache. First container you install Apache, then you will commit a image. Okay. So this image has Apache installed in it. Then you will create a second container. That is where you will set up the startup program. So you will take the previous step image and then from that image you would create a new container. And inside that container you will set up the startup program, whatever command it is. You want to execute it. When I say set up the startup program, basically configure this command to run automatically. That's what I mean, right? I'm not running it. I configure this command to run automatically inside the container. That's what I want to do. After that, I want to create a final image. And this final image consists of, it's not final image, it's a temporary image. This consists of Apache. It consists of the startup program also. Now on top of it, next thing what I want to do is, I have the latest build folder that I want to copy. So I want to copy the build folder. So I will create a new container from this image. And then in that container, I will copy the build folder. Then I will commit a final image. I want to do it step by step. Why do I want to do that? Because I want to use the caching efficiently. My developer on his laptop, he make the code change, right? Developer on his laptop, he change the code. Then I have to again create this final image of my application. So CoIT frontend code changes. I want a final new CoIT frontend image. It changes at 10 a.m. It changes at 11 a.m. Every time the code changes, I want to create a new final image. And these are cached images, which I will reuse every time I create the final image because the code change, that means the build folder change. There is no change to Apache installation. There's no change to the default program. The change is only for this particular step. So this step I want to rerun and this image will change. So the other two images I will simply reuse, right? So this is how you should be developing the container image step by step, using the efficient caching. And also when you write step by step, the first steps are the steps that don't change very frequently, right? In your company, think about your CoIT frontend application. The build folder continuously change. I know my developer do the coding, the build folder continuously change, no doubt about it. And it changes every day, every few hours it changes. But how about the Apache installation? It doesn't change a lot. It's a one-time action to install Apache. It doesn't change a lot. The startup program don't change a lot. Maybe Apache latest version has a different command. Maybe, but its chances are very rare. These two things will change a lot. Whatever that doesn't change a lot, you want to do it in the beginning steps. Whatever change a lot, you would make them the last steps. So then only the caching will be efficient because let's assume first you are doing the copy build operation. So build folder is changed. So copy build operation will be executed and the image get cached. Now all the subsequent tasks would become invalid. All cache would become invalid. Now Apache, all these things has to happen again. Apache install or everything has to happen again. So that is why I said, when you are doing layer by layer, the beginning steps should consist of those steps that don't change a lot, right? If you want to use caching efficiently, otherwise what happens is when the build folder get copied, the image got changed, then all the remaining images would become invalid. You don't want that. You want you want to do things in such a way that you want to use the caching as much as possible. So these images don't change a lot. So those steps don't change a lot, put them on the top. Those steps that change a lot, put them to the bottom, right? That's how you should be developing. And yes, you should be writing it as instructions. You should not be doing this manually again, right? You should not be creating an image from Ubuntu. Then on top of it, you want to install Apache. Then you want to, right? You should not be doing it manually. Instead, you should be writing them down inside a file that for automation, right? This whole process need to be automated, setting the base image, right? For that, you will use a line called from Ubuntu. So this line you put on the top, that would set the base image. Then after that, you have to specify, I want to install Apache. And so there is a command called run followed by any Linux command you execute. So you can run apt-get update and apt-get install Apache. So what this particular command does is, the run statement, if you put inside this file, inside this is called a Docker file. And if you put the run statement inside a file, then it would execute this command. It would create a container from the base, from the previous step. It would create a container. This command, it execute inside the container. Then it would commit an image and cache it, right? And then next thing what I want to do is, I want this startup program to be set. This I want to be the startup program. And if you want to set a startup program, there is a statement called CMD. So using the CMD statement, you can decide whatever startup program that you want to set. So I do that. So CMD statement would set a startup program. So what this command does is, it would create a container from the previous image, set up the startup program, and do whatever step needed to set up the default program, and then commit another cached image. Okay. And if that is also completed, then the next step, I say I want to copy the build folder. So I put a copy statement. If you want to copy something from your local, so assume from the Docker host, you have a Docker host, that is where you will execute this file. And there is a build folder that you stored locally. And that folder you want to copy to the container. You type www.html. So what this statement does is, it would copy the build folder to the www.html of the container and commit a final image. This is your final image. And you will keep this file with you. You'll keep this file with you. Every time you want to create an image, you just execute this file. Think about that. That's pretty straightforward and convenient, right? And automated. You don't want to do all these steps manually. Every time your developer make a code change, you just execute this file and all this process will happen automatically and your final image get created. That sounds great, right? So this is how the companies develop container image. And this file is generally named, you can give whatever name that you want to give to this file. It is called Docker file. It is, as a best practice, you name it Docker file. And these are the instructions that you write down inside the file. Whatever instruction, starting from Ubuntu until you get the final image, what are the intermediate layers of cached image that you want to create? You write them step by steps, and also make sure that whatever that doesn't change a lot, put them on the top. Whatever that change a lot, put at the bottom, right? So that the caching will be efficient. Otherwise, any one of the steps change, then every below steps has to rerun, right? So you don't want to do that. So whatever that doesn't change a lot, you put them on the top, and then the cache will be more efficient. The build process would be much faster, and this is very very important actually. Otherwise, your developer won't have to wait a lot of time until the final image get created. If you don't use caching efficiently, it's very very important that you follow the best caching practices. There should be an order at which you should be writing down the instructions in Docker file. Whatever change a lot, put them at the bottom. Okay, great. Now the next thing, so we discussed about there are two things that you should do when developing a Docker image. One, you should automate it. It shouldn't be a manual job. It should be an automated job. Second thing, you should use the caching as efficiently as possible. And we also developed a Docker file and how exactly a Docker file look like you have seen. So that's what I'm going to do. I'm going to get that Docker file. Using that Docker file, I'm just going to create a container all by myself, right? All by myself, I'm going to create a container of the CoIT front-end application. So I have the code. I have the code that is currently located inside my AWS machine, inside my Docker host. I already have this code. I have the CoIT front-end folder. It consists of everything. It consists of the build folder. It consists of a Docker file. I mean, I'm going to create a Docker file all by myself. And I'm going to name it. Generally, it's called Docker file, but in my case, I already have some Docker file here. So I'm going to call it Docker file Apache, right? I'm going to call this file Docker file Apache. Whatever file that I have just created, I'm just going to copy paste it. So that's what I'm doing. I just copy paste it. So this is my Docker file, and this file consists of the instructions to build my image. So you start from Ubuntu, then you run the command apt-get update and apt-get install Apache 2. That would using run statement. Then with CMD, I don't think you need the double quotes. You can simply put this. And using CMD, you are setting the startup program, and using copy, you are copying the build folder. The build folder is already there with me. Locally, this is the build folder I created in the last session. So it's already there. So all I have to do is just execute this file. Actually, I'm going to do one more thing, because when you run the apt-get update command and apt-get install command, apt-get might ask you what is your time zone, some information like that. I don't want that. So this is what you can do. You can set an environmental variable, Debian frontend equal to non-interactive. So this command, it's a good idea. If you are using Ubuntu image, it's a good idea that you put this environmental variable. This would set an environmental variable inside the container. And if this environmental variable is set, then apt-get will not ask you further questions. It would take the default settings and proceed. And you should use -y option. Otherwise, apt-get asks you yes or no. Do you want to continue, yes or no? I don't want that question also. I want it to be automated. So I put -y. Apt-get will go ahead and install. It won't ask you yes or no. And right, that's all. So I have this Docker file, and it has clear instructions on how to develop image, right? So I'm going to develop an image all by myself. So I am on a machine. The only thing is that the machine must have Docker installed, which is already there. Docker is already installed in this machine. And then using Docker, I'm going to create my CoIT frontend application. And I already created the build folder. For that, you have to run npm install npm run build. So I already have the build folder with me. Now with this build folder and with this Docker file, I'm just creating my final CoIT frontend application image, right? The command is docker build -t. You have to tag your image. You call it some name, CoIT frontend local, whatever name that you want to call it, or you want to call it V20, it's up to you. Call it V20, whatever name that you want to call it. Then you specify dot means it is the current folder that I want to consider as the context. Dot means current folder. So it is in my current folder, I have the build folder. So I have to specify where I want to execute this command from my current folder. Then -f, you can specify what is the Docker file that you want to use. So you can specify the file name, Docker file Apache, the file that I have just created. So what I did is I created a file, Docker file Apache, and inside the file I have specified all these instructions. And then after that I came to the CoIT frontend folder. That is where I created the build folder. So from that folder, I am executing the Docker build command. Docker build command will read this file, execute the instructions line by line, and it would finally create this image. This is the image I want to develop. The name of the image, I give it some name. So this would be the final name of the image, whatever I am developing. And yes, in between, it would create a lot of intermediate layers of cache, right? There will be total, how many lines are there in this file? I think 5 lines, 4 lines. So there would be three, four images, intermediate images that get created. So just go ahead and run this command and let's see. Yes, it's starting. So the first step is from Ubuntu, and it is not pulling from hub.docker.com because remember I already pulled it by using docker pull command. I already pulled Ubuntu image previous last time, so it won't pull again. So it already have that image. This is that image. Then it is setting the environmental variable. It's creating a temporary container, and then it is committing a final image, and it removed that temporary container, and this is the final image that consists of this environmental variable. Then you want to install Apache. Again, it would create a temporary container, and inside that container it will install Apache, and finally it will commit a final image. This is the final image. Then then it's setting the startup program again, creating a temporary container and committing a final image and deleting the temporary container. And at the end all the steps are completed, and you created this image. This is the image that you have just built, right? So you built it yourself, right? All you had is a Docker file. All you had is a Docker file. And yes, whenever you want to build an image, you use a Docker file. So it's only for CoIT front, and you want to do the same thing for CoIT backend 1. You want to do it same thing for CoIT backend 2. Whatever application your company have, shopping cart, prime customer, whatever application your company have, it must consist of a Docker file with clear instructions on how to build the final container image of your application. And that's the only file people need when you want to develop an image. And yes, a machine with Docker installed in it. So any developer in your team, they have Docker installed in their laptop, and they have this Docker file with them, and they have the CoIT frontend folder with them in their laptop. They can just execute this command to build the image. Anyone in your team, any systems in your company. So a single command can be used to create your container image, final container image. Sounds perfect. So this is how it works, right? It's important that you automate the process of building. So every application should have a Docker file. Shopping cart has a Docker file. So this is right. CoIT front and Docker file you have already seen. CoIT backend 1 should have a Docker file. CoIT backend 2 should have a Docker file. Every application in your company should have a Docker file, and then with a single command, you can build container image. Not just you, whoever has this CoIT frontend folder, whoever has this Docker file, whoever has Docker installed on their laptop, or right. So any machine in the world can execute this command and build a container image. And after building the container image, the next thing that you want to do is you want to store this container image in a registry, right? Make it downloadable by other people, other systems, right? Put that in a registry and share it with others. That's what you want to do next. So yes, right now I run the command Docker images. Yes, I can see the image is there, the CoIT frontend V20 image that I have just created 2 minutes ago. It's there, it's created, it's 227 MB small size. Now it's time for me to push this image to the registry hub.docker.com. So I have already executed the Docker login command. That's a one-time command. Currently, I am logged into hub.docker.com to my account. I can simply run the command docker push. Before I run the command docker push, I have to tag it respectively. So the current name is, the local name, what I called is CoIT frontend V20. I'm going to tag it something like this, CoIT learning / CoIT frontend V20. So you should tag it like this. Docker IO is optional, right? If you want to put Docker IO, you can put Docker IO. It's optional. You don't have to put that. So first you should tag it, and now you run the command Docker images. You can see the new tag. It's there. The new tag is there. Now it's time to push it. The command is Docker push. Docker push. So I have created an image myself inside my local, and then using Docker build command, I tagged it. I am pushing it to hub.docker.com to the registry, and so that other people in my team can get access to it, right? So this is a process that I have to continuously do, right? Building the image and deploying the image, storing the image in a registry and share with others, right? That's important. That's important. Now it's there. I can go to my hub.docker.com account and then I should be able to see this, right? I should be able to see this in my hub.docker.com account. Let me log in to hub.docker.com using my credentials, whatever I have. My Docker ID is CoIT learning and my password. So using my credentials, I will log in. Then I can take a look at if the image has come here or not. So I have the CoIT front-end repository here. And yes, V20 has come here, right? Click on V20. I can see it, right? This is the image. It has come, right? It's awesome. Great. So this is the whole point. I have got my, I created my own application I built as a container. And then that container I stored inside the registry to share with other people in my company or in my team. Perfect. Next thing, I want to share this image, right? Share the image with others, right? I have created this image, it's stored in the registry. Now it's time I want this image to be shared with other people. Yes, I want to share it, right? Because my container registry in my company, the container registry what I have in my company, it want to store the final container images, right? It consists of my various container images that my company develop and push. It would be stored inside the container registry continuously, right? The CoIT front-end application, CoIT backend application, my company want to have a container registry that is where all my application images would be stored. They are stable version, unstable version. So it's all there inside a registry. That's what I want to do. I want to keep on pushing my container images to the registry, my different applications in the registry, and then various systems, maybe a Kubernetes cluster in my company, or maybe a developer in his laptop, or maybe a machine in the cloud, your Jenkins server. They want to run the containers. They will be downloading these images from the registry, right? Various machines in my company, they would be doing that. They would keep downloading the container images from this registry, and then they would be creating containers inside. That's what they do, right? I want to create containers inside various places. So that is why the importance of container registry. So after pushing this image, you should have to decide who will get access to those images, right? That is important. So you can share it with the people. So after pushing the image to your container registry, you can go to hub.docker.com, log in using your browser. And over here, there's an option called Collaborator. And then I can share with other collaborators in my team. So if Basil Varghese is a user who need get access to this container image, I can just add him just by clicking the plus button. And if you created a Docker ID for yourself, you give me your Docker ID. I can put your Docker ID over here and click the plus button, and then you will automatically get permission to this. If you log into your hub.docker.com, you can see this image if I added you. So like that, I can share, I can ask everyone in my team, hey, all of you go to hub.docker.com, create yourself a Docker ID and send me a Docker ID, and I'm going to share it with you. So I will share this image with them, and they can log into their Docker Hub account and they can see the container images there in their account, right? So it works pretty well. And this is how I can share this image with others. And right now, this image is public. Currently, this image is currently created as a public image. And I want to change it, I can change it. I can make it private if I want, but it's costly. For that you have to buy it. You can create one private image, but you cannot create more than one. For that you have to pay. So it's $5 per user that you have to pay to the hub.docker.com if you want to create private images. By default, it's public. That means anyone can pull it. Without a Docker login, you can still pull it, even if I didn't add you as a collaborator. But if you want to push it, I should add you as a collaborator. That is important. For now, this image is downloadable by you, right? You can simply run this command all by yourself. You can just execute this command, right? You can simply execute this command yourself. Anyone in the world now can execute this command, because this image is public. Generally in company, it's not public, but in your particular case, if you want to run a container all by yourself using my image in hub.docker.com, just execute this command, docker run in your laptop, coit learning / CoIT frontend. Just run this command in your laptop, and then a container will start running in your laptop. This get downloaded. It's a public image. Anyone in the world can download. So this command will work for you, right? Command will work for you. Uh, that's the whole point. And yeah, but generally in companies, I should add you as a collaborator because you don't have pull permission. Also, you don't have push permission. If you run the command docker push, you will get an error because even though the image is public, it's public readable, not writable. So you cannot push, right? Without proper login, you cannot push. If you want to push, I must add you as a collaborator. So that's the whole point. And this is how I can share my container images with other people, other systems within my team. And also, it does not has to be hub.docker.com. Most companies uses whatever solution provided by their cloud provider. If you are using Google Cloud, you can go with GCR. If you are using AWS, you can go with ECR. So every cloud provider has a registry similar to hub.docker.com. So it is optional. The companies may be using different container registry. Whatever container registry it is, you can have configuration for authentication and authorizations. You can share, you can create different uses, and different people in your company can log into the same registry, push, pull, right? All these things they can do. So a container registry, whatever container registry you are using, whether it is hub.docker.com or your cloud providers, it doesn't matter. It should support all these things. It should support people all over in your company to be able to log into the registry, push pull to the registry, right? They should be able to do all these stuffs all by themselves. And what you should also want to do is, yeah, I think that's it. So you should be sharing this with your colleagues, and whatever registry you are using. Finally, everyone should get authorization to access this container registry and your container images, right? Perfect. We'll talk about a few things. So let's first talk about one thing: changing the container image, right? So actually, let me log into the AWS machine. That is where we have been working. Yeah, this is the machine where we have been working. And inside the machine, we have already created a container image for CoIT front-end applications, and we have pushed it, right? So that is already done. Now the next part, we are going to make a small change in the container image. So inside hub.docker.com, let me go to the CoIT frontend. Actually, there are various Docker files that I have written here. I mean, we can use any one of the Docker file, but let's take a look at this one, the Docker file multi-stage. This is the most recommended way of writing the Docker file. And inside this Docker file, I mean, this is the one what we have written in the last session, right? When we were discussing Docker file, there is one more Actually, there are three other Docker files that I have written in the same folder. You can go through them, and the most important one is Docker file multi-stage, and it consists of some best practices what I have done. So you can actually see this is this is quite front end, and it consists of the wrong Docker file. Okay, yeah, let me show you this. I'm going to open this file. Yeah, take a look at this file, the Docker file, not Docker file multi-stage. It's Docker file for CoIT front-end application. So go ahead and take a look, and you can actually see it consists of only 2 lines. So what I had done is, rather than starting from Ubuntu, then installing Nginx, I directly started from an official Nginx image in hub.docker.com. Rather than starting from Ubuntu from scratch, you can actually look for an image that already contain Nginx. In that case, you don't have to worry about installing Nginx, and you don't have to worry about starting Nginx, because Nginx startup program will be already set inside this image. You can simply use this image, your preferred tag. There are various tags available. So in my particular case, I'm going to use 1.20, right? 1.20 over here. This is the one that I am using. So I start from there, and then from the documentation itself, they had given clear instructions. This is a Docker file that you can write yourself. Into this document root of Nginx, you can simply copy the build folder. So I have written those instructions, start from Nginx and then copy the build folder. And similarly, for the CoIT backend also, CoIT backend one also, I had done the same thing. And in this case, again, there are 2 Docker files. And if you open the first Docker file, you would find some simple instructions. And again, here we are starting from not from base Ubuntu image, we are starting from OpenJDK. OpenJDK is an image which already consists of JDK, Java Development Kit. So it has Java, and it's a good idea because this is our Java application. And in order to run our Java application, first of all, we need Java. So rather than starting from Ubuntu and installing Java yourself, we are actually we are actually taking a OpenJDK image from hub.docker.com and using that. And after that, we are setting the CMD. You already know this command, java -jar, then the name of the file, and then you have to specify the URL of the Python application. If you remember, at the time of starting Java, you have to specify the Python application details. And then finally, you are copying the jar file to the container. So copy command or add command you can use. It's fine. And then the jar file get copied into the container. So these things I had done, and actually that is the basics instructions of. And if you take a look at this file, that consists of some best practices that you can go through. Open the file, Docker file multi-stage, and in this Docker file, things looks a little bit different, right? It looks a little bit different. Inside this Docker file, I am building the jar file also. Take a look, right? There is 4 steps over here, and then there are a number of steps over here, right? So I have written in 2 steps. In the first step, what I'm doing is I'm taking a Maven image from hub.docker.com. Yes, there is a Maven image in hub.docker.com. I am taking that image. I'm starting from there, and then I'm going to name that stage as build. So this is called multi-stage building. So in Docker multi-stage building, you have the ability to create multiple stages. So the first stage is all about building building the jar file. So you can see we start from a Maven image. It already consists of Maven, so we don't have to install Maven. And then what it is doing, it is setting the default folder and then copying the current folder, that is the Java application folder, including src, I mean the entire Java programs. It is copying to this particular folder inside the container, and then it is executing the Maven install command. You already know, when somebody run the Maven install command, what happens is a image get created, sorry, a jar file get created, and then we start the next step, right? This is the next stage, and you can see we are starting from another base image, OpenJDK. So this is the first stage. In the first stage, we will create a jar file, and then we start from the scratch again. the reason why I did in this way is, if we do the multi-staging, so in my particular case, I need a production image, I need a container image to be created that consists of the jar file, and that will execute the startup program. That is my intention. But at the same time, I want to build my Java container image. I want to build the jar file. So creating the jar file, I have to do inside the Docker itself, rather than doing developer directly running Maven install command in his laptop, creating the jar file and then copying the jar file into the production image. I don't want to do that. I want that two-step process. I want my developer to write the code and then he execute the Docker build command. It should automatically create the jar file and then it should create the final production image. And while creating the final production image, I want to copy the jar file to the final production image, right? So that's what I am doing here. Copy from build, right? This is an extra statement that you see. So I want to copy something from the build step, right? This is the build stage, where I created the jar file, and then in that stage, from that jar file, this is the jar file that I want to copy from the previous stage. Maven install command have already created one, and this is that file which I will copy to my final container. So this is a good idea, because a developer does not have to run the Maven install command himself. After doing the coding, he will execute one single Docker build, and it will first build the jar file, then it would create the container image. And also one good thing is that inside the container image, it will consist of only the jar file. Now you don't really have to copy. So the reason why I did it in two stage is, in the first stage I will do the building, and the first container will consist of source code and Maven, and right, a lot of things the first stage will consist of, and I do not need such kind of things inside my final image. Inside my final image, I need only the jar file, nothing else, right? I need only the jar file. So that is why I did it in this way. I am copying only the jar file to the final image. So this is the final image that would get created. And this is the file. This is the best practice to write a Docker file, right? And this is how you should be writing the Docker files. Okay, guys. So now I have, a number of, I have the Docker file with me, and I can start building my Java application. So I'm going to use the command docker build -t. Then you can specify the name of the image. Let's say CoIT backend one. That's my Java application. And let's call it V11 or something, whatever name that you want to call it. The tag, and then you can put a dot to indicate that it is the current folder from which I want to run it. And -f, I am going to specify the Docker file name as Docker file multi-stage. So this command would, and remember, I am building the Java application container image, but I'm not writing step by step in one stage. I'm doing it in two stages. In the first stage, so even without the target folder, you don't need the target folder here, because inside the container it will build once. So a developer can write the code, make the code change, and then he can simply execute this command. It will build the image, it will build the jar file, then it will build the final image, and the final image will consist of the final jar file. So you can see Docker identified that there are two stages. So it is starting with the first stage. It is starting from the Maven image, and it is trying to build, right? It is trying to it is currently downloading the Maven image, and then after that it will copy the source code, copy the current folder to the container, then it will execute Maven install, and it would create the jar file. Then after that, it will start the next stage. In the next stage, it will take that jar file, take a OpenJDK image, copy the jar file in it, set the CMD and stuff, right? So that's what it will do. And yeah, my one install is currently running. And yeah, let it go, right? And so that's the idea. This way you can actually build and push CoIT backend 1, CoIT backend 2, right? All the applications. So in the meantime, let me also show you the CoIT backend 2 application. I'm going to log into the machine once again, the Python application, which I hope you remember. How did you run it manually? So go to the Python folder, which is CoIT backend 2. So that is the Python folder, and inside this folder, you already know, it has the Python program, it has a file requirement.txt, which consists of the module. So now let's take a look at the Docker file. Open the Docker file and you can see the instructions, and this is not a multi-stage, this is a single stage Docker file. And over here, basically it's taking a Python image from hub.docker.com first. Inside the hub.docker.com, there's a Python image, and on this Python image, it is setting the default folder as /app expose 5000 to set some the port number, which is not mandatory. Even if you don't container listen on 5000, then entry point on CMD together you are putting. Yes, you can actually put CMD as Python 3 space this program, that is the actual command that you want to run. Even if you put entry point and CMD both, then the actual command would become Python 3 space sentiment analysis.py, whatever you put on the entry point space, whatever you put on the CMD. So that is the command what you want. And even if you remove these two lines and replace it with a single line, CMD space Python 3 space file, that will also work. Okay. And then it is copying the code into the container. Then it is executing the pip install command, and then things like that. It is installing all the modules, and that is the Python code what we have seen. So using this Docker file, now I can build a Python container using the same command, docker build -t CoIT backend 2, and that is the name of the image that I am trying to build, maybe v11, or I give some name -f docker file. And if the file name is docker file, you don't have to put docker file, because by default it will take that file only, right? And there is a docker file, and you don't know if the file name is docker file, you don't really have to explicitly mention the file name. Using the docker build command, it will automatically take. So now just run the command, and then it would start building the Python image. And in the meantime, the Java image is created. You can run the command docker images. You can actually see the Java image got created, and now similarly the Python image will also get created very soon. So basically, what you do, it's done. The Python image is also now created. You can run the command docker images to see all the images: the backend 2 image v11, backend 1 image v11, front end v11. So we created all the 3 images of our application. So right, all applications we have created image, and I also told you, try to use the multi-stage building. That is always a very good idea. And then now all the 3 images are ready. Now it is time to push the image to your hub.docker.com account, the registry. All these images need to go into the registry, and in order to do that, first of all, you should have a hub.docker.com username, and I already told you, you can go to the website hub.docker.com, and then you can sign up yourself. And in my particular case, I already have a credential, and that I'm going to use to log in. Username is CoIT Learning, and then the password I'm going to enter, and I am logged into the hub.docker.com. That is a place where I can store different container images. So I already have CoIT Learning, CoIT Backend 1, CoIT Learning, CoIT Frontend, CoIT Learning, CoIT Backend 2, etc. Already I have, because I previously, some 23 days ago, few days ago, I had already pushed these images while I was doing something. But yeah, right now I'm going to push V11 version of this image. That's what I'm going to do. So first of all, you should tag it, right? I already talked about how to tag a image. Docker tag is the command that you should use. And before pushing the image, you must tag it. So all the images I'm going to tag. First one is CoIT frontend v11 minus then you should give the right name CoIT learning. Whatever your Docker ID is, when you sign up at hub.docker.com, you would get a Docker ID. Whatever your Docker ID is, in my case it's CoIT learning slash then whatever name that you want to call this image, the repository. So this is how you will tag it. And I'm going to tag all my images. Now it is the CoIT frontend. Now I'm going to tag CoIT backend colon v11. I'm going to tag it, in this format, CoIT learning slash whatever your Docker ID is, right? Slash then CoIT backend 1. And similarly, I'm going to also tag CoIT backend 2, right? V11. So I tagged all the images, and remember, tagging simply means giving a proper name, right? This is a local operation that I am doing within the same machine. And now before you push, you should do this kind of local tagging to match the naming convention, whatever your registry follow. And if your company is using a cloud provider such as GCR, Google Container Registry, then the tagging will be gcr.io slash, that is the host name of Google Cloud Registry, slash then whatever your project name is inside your Google Cloud, and then the repository name. So if you are using anything other than hub.docker.com, you can follow this syntax, right? So in my case, it's hub.docker.com. So I tagged it in this manner, and now I want to push. So if I want to push, first I should log in, right? I will run the command docker login, and then actually, in my case, I have already entered the credentials. In your case, it will ask you for your hub.docker.com username and password that you have to enter. Okay, and once you did, it will tell you the login is succeeded, and now I can start pushing the container images, and that's what I'm doing. Docker push followed by the container image, right? The front end image. Next thing, my Java application image, and then my Python application image. All the image I am pushing to the registry. Okay, that is done. And now the next thing, CoIT backend 1 image I'm going to push, and similarly a CoIT backend 2 also I am going to push. It's done. Now CoIT backend 2 also I'm going to push. So I have pushed all the images into the registry. That is what I have just done. Now all images are pushed into the registry. V11, CoIT frontend V11, CoIT backend 1 V11, CoIT backend 2 V11. All these images have now been pushed into the registry, and you can log into the registry and refresh the page, and then you would actually see a minute ago CoIT backend 1 is pushed. A minute ago CoIT frontend is pushed, and CoIT backend 2 is currently being pushed. Yeah, it is done. It is pushed now. And CoIT backend 2 also, it got pushed a minute ago. And if you want to see that image, you can click and open it, CoIT frontend. Then over here you can see the V11 got pushed a minute ago. Different tags available. And now I can see my container images in hub.docker.com. Now I want this image to be shared with my other people in my team. There are options available for me. There is a menu called Collaborators, and then I can add the Docker ID of the respective people. So it's in my case it's already there. So this is the list of people who have currently access, and if I want to add access, all I need to do is I can specify the Docker ID of the people who need access, and then I can add this plus button. Now this guy is given access to my container image. So this way, if you are working as a team, everyone can register at hub.docker.com. Everyone can get a Docker ID, and then one person can share the container image with everyone in the team using their Docker ID. And once the container image is shared with somebody else, they can log into hub.docker.com with their credentials, and they can see this image in their account. Then they can execute the Docker pull command, Docker push command, right? All this command they will also be able to execute. So that is what you want to do when you work as a team. There are different people, and different people need to have access to the hub.docker.com because they want to share the container image, right? Because they all work in the same team. Whatever image that come here, people want to push it, people want to pull it, people want to run containers locally in their laptop, and they want to do such kind of things continuously. And in order to do that, you would need to give permission to all of them. So one administrator can log into hub.docker.com, and then he can add the collaborators from this particular page, and then whoever he added will get the permission to read and write to this particular image. So that is how it works, right? That's how the hub.docker.com works. Perfect.